Hi, we're here today with Ron McMorris, Lordco Auto Parts Engine Division Manager. We're here at the Langley location, and we're here to build an engine for Project Shovelle.
Yes, we are.
So, let's get right into it and let's talk about the block.
Okay. We're starting this build with the Dart SHP block, which is a great foundation for this build. What it is it's Dart's entry-level block. It has a lot of great features to this block. It has priority main oiling, it's got extra cooling on the block, it's got the provision for an OE-style hydraulic roller camshaft, which keeps the cost down because everyone's got a budget when they're building engines.
This is a budget build, so
it
fits in perfectly. So what sort of machining did you have to do prior to assembly?
These blocks come in about 5 to 10 thousandths high in height. So you can machine the block, parallel deck the block to get your proper piston height in the block. So you want to have.
You say parallel deck. What do you mean?
Parallel decking is basically taking from the crank center line to the deck of the block, making everything parallel with the center line of the crankshaft. Okay. And you will machine it to a certain height, so you get your proper height of where you want your pistons in the block. So you want them 5 thousandths down, 10 thousandths down, 0 deck height. You can custom tailor that block for your needs.
Okay, great. And can you tell us a bit about the rotating assembly?
Well, the rotating assembly, we've gone with a 4340 scat crankshaft.
Okay.
Simply for strength. On a 4340 over a cast, you've got an awful lot of strength in there. We've gone with an I-beam rod with a 7/16 4340 rod. And we've gone with the Molly Motorsport piston, 4032 forging, with what they call their power pack piston assembly.
Great, great. And what was your choice for the camshaft?
Camshaft, we went local. We went with Interior Cams out of Salmon Arm, BC. Okay. They took an OE General Motors hydraulic roller and they custom ground it for this engine. We spoke to them about the engine, what we're building, what we wanted to do with the engines, and they tailored this camshaft for the engine. One thing about Interior Cams, they're local guys. They can grind a camshaft as good, if not better, than any of the big name guys out there. They're a small operation. Pay attention to a lot of detail.
Right. I understand they're even coming up with a website recent.
There we go. Yeah.
Upcoming. So
these guys they're really good. These guys got ISO certification. They do aircraft camshafts. They do everything. They're capable of doing anything that you want.
Oh, excellent. Let's move on to the cylinder heads.
Cylinder heads. What we chose on the cylinder heads, we went with the Dart Pro 1 Platinum heads. It was kind of a toss-up between with the 180cc and the 200cc. We chose the 180cc because for this particular build, we're trying to build mid-range torque. Smaller intake port, better velocity, we'll build better torque numbers. We probably would have got a little bit higher horsepower out of the 200cc head, but we're not trying to build horsepower here. We're trying to build torque and reliability. That's the whole thing about this engine. Okay.
And you went with a little different choice with the pistons?
Yeah, the pistons, what we opted for was the Molly Motorsport piston, which is a very unique design. It's not what the old school piston is all about. It's got a lot of unique features. These pistons, this is actually not.
Oh, you just happen to have one.
Just happen to have one right here. This is not the piston of the engine. Actually, the ones that of the engines are these, but very similar design. What these big features on these ones are is they're very short skirt design. They have a very short pin. When they have a short pin like this, there's a lot of weight that's taken out of the piston. The other thing about having a short pin is you got a lot more stability, a lot less chance of flexing. So that's good. The other thing about these things is the way that they're machined in the ring area here, on the flat of the ring, that is a big point of sealing. Everyone thinks that a ring seals against a cylinder well. Well, that's true to a certain extent, but also it seals on the bottom portion, what they call the flank area of the piston. Okay. It's very important to get a good ring seal there. These pistons and rings are very precisely machined in that area, and they give you a great ring seal. Another couple things about these pistons is they have 2 coatings on them. They have what they call a graphol coating, which is this gray coating that you see all over the whole piston, and that primarily is there for breaking in the pins on initial fire up, so you don't get any galling in the pins. It's also there for the rings, so they seat, so you don't get micro welding of the ring to the aluminum piston on initial fire up, which is a big problem that people don't even know about. Right. The other thing is they have the skirt coating. Now this skirt coating is actually a phenolic-based membrane, and phenolic is your typical carb spacer is a phenolic material. Okay, and these actually go on to the silk screening process and they work as a cushion. So as this piston goes down and rocks, when it comes up against the cylinder, when it's on the bottom of the top of the stroke, it actually cushions. It eliminates a lot of piston slap noise, and also gives you a much better ring seal because it gets away from the rings fluttering from the rocking.
So I understand these are also quite a bit lighter than your standard pistons.
Yes, they are. Just simply by the skirt design being so much shorter, your typical old school piston, it's got a skirt that's going to come down to about here. These ones are a short skirt design, and also with that short pin in there, that also reduces a lot of weight, which is great for performance applications.
Excellent. So how are we pumping the oil into this one?
Well, for oils on this particular block, what we've chosen is the Milling Select 10550, which is a standard volume pump. High volume pump, everyone thinks you need a high volume pump. It's not required, especially in an SHP block.
Why is that?
Because of the priority main oiling that's in the SHP block, it's not required. And also the tighter tolerances within the oil galleries. The oiling system on an SHP block is called priority main oiling, which means it comes out of the pump into the oil galleries and goes directly to the mains. Okay, instead of going to the cam bearings where there's a lot of leakage, and then going down to the mains and forward to the rods. This goes to the mains first, so it feeds the crankshaft first of all, where all of your extreme pressures are happening within an engine.
So tell us, did you balance this engine?
Yes, absolutely. Any performance engine needs to be balanced, especially when you're using different combinations of parts. You have one supplier of pistons, one crankshaft, different harmonic balancers, flywheels, all these things. They're not a matched unit to start with. We're putting a bunch of stuff together. We're making it a matched unit by balancing it.
I see. So if you are dealing with a complete OE application, you wouldn't balance the engine?
We like to balance every engine. But in an OE stock replacement, what we would normally do, if someone is not in the budget to balance it, we will take the original piston, we will weigh it, take the replacement piston, and make sure they're close. And if they're close, then it'll go together as an unbalanced unit. And in a stock application, it will work. But every engine, there's a lot of benefits from balancing, and I highly recommend it on any build that you do.
Okay. So let's move on. How are we going to stop this engine from leaking oil? What sort of gaskets are we using?
Nobody wants an oil leak.
Nobody.
That's the last thing that you want. You got your beautiful hot rod, and then there's that big puddle underneath. You do not want that.
Right.
So what we've chosen Velcro performance gaskets. Okay. Starting with a good quality performance rear main seal, one-piece oil pan gasket, and then the most important gaskets, cylinder head gaskets. We've chosen an MLS gasket for here, which is a multi-layer steel. Multi-layer steel gaskets have really come into play in about the last 15 years. You started to see them on a lot of imports where you have a cast iron block, aluminum head. Now in a lot of our performance applications, obviously we are cast iron block and aluminum head like in this build. MLS gaskets have extreme sealing capabilities, and with the multi-layer shims, as it actually crushes down, it gives you a fantastic seal. We'll also handle extreme pressures for nitrous oxide, turbocharging, supercharging, that sort of stuff. It eliminates the reason to O-ring a block nowadays. People don't even O-ring a supercharged anymore. They use a good quality MLS gasket, and it seals the engine up fine.
Interesting. Other than the fact that we had all these generous sponsors that donated the parts to this project, what was the reason for the combination?
We chose to build this engine this way for a reason. It's in a 68 Shovelle. It's a heavy car, 3,800 pounds. We need some torque to get this rolling. Basically, we're building a small block with big block torque numbers. That's what we're building. We chose a camshaft that's going to give you good mid-range power. It's not too aggressive. There's still going to be some good drivability with the thing. The compression ratio is roughly just a tad over 10-to-1 compression. But with the aluminum cylinder head and the way that it dissipates the heat, you can get away with a little bit more compression with the camshaft and the duration. It all works out well.
What is a compression?
The compression. What is the compression ratio on this?
Yeah.
Compression ratio on this will be about 10.2 to 1.
Okay.
By the time it's calculated, we'll have to double check a couple things on it, but that's what we're looking at is 10.2 to 1.
And the projected horsepower, torque?
This engine, the way that it's built, it should be in the mid fours, 450, 460 on the horsepower, and 470 on the torque number. Should be right around there from what we designed. We'll find out when we go to the dyno, but it's going to be in that area. So basically, you got big block power and a small block. That's the beauty of these new blocks and the capabilities of the larger cubic inch in these blocks.
Well, that's fantastic news for all of us that will be driving it. Let's bring in Ron Croteau, who's going to assemble this motor. Ron, you've been with Lorco for 12 years now. You've been an automotive machinist for how long?
I've been in the trade for about 30 years now.
Oh, wow. So we're in good hands with you.
Yes.
Great, great. I know you've done some prep work before assembly today, so maybe you can take us through that.
Okay, so what we've done is we've bored the block to fit the pistons correctly with the proper clearances that are required from the manufacturer, because all manufacturers require different clearances.
Okay.
We've also did some fitting of the rings, so we have the proper ring gap, because that's an important feature on, again, depending on usage of vehicle, nitrous, blown, all those require different ring gaps for expansion, for the heat.
Okay.
We've also, we put the block together, sort of dummied it together, as they say.
Okay.
Check the corners where the pistons are sitting in the block. We wanted to have the piston sitting in a certain location as to clearance. Then we deck the block to fit what we want for what we've designed for this engine.
Okay, so, and everything checked out okay?
You bet.
I see I see you've also painted the Chevy orange.
Yes.
As per
your request.
Thank you very much. It looks great. Let's get going. Where we're going to start?
We're going to start by, first off, we're going to slide the cam shaft in the cam bearings, and then we'll bed the crankshaft, and then we'll slide the pistons and rod assembly, and then we'll have a rotating assembly in the block, timing chain, and then we'll put the gaskets on to put the pan on and timing cover on, and then from there we'll move on to cylinder heads and valve train.
Excellent. And we'll be racing by?
Soon.
Great. Well, let's get started.
Okay.